Okay, so we should be live now with the second set of 3 presentations for CET498. The running order for the presentations is as on the screen there. We've got Coffee King will be up first, then Bear Aware Alarm, and then Aqua Drone. Just to remind everybody where we are, we've been doing the prototyping and detailed design part of the process, and we're right on the right hand edge of that red box, right? We're doing the detailed design review. Once we finish that, we'll be heading into the final design and making sure we have a working prototype. Well, as working as we can. Okay. The piece, I should have grayed out the top 3 bullet points here, but the piece we're doing today is the detailed design presentation, and by the time we get that done, right, we'll have what's that, 35% of things done, plus a bit of that 20% for the weekly status meetings. I don't think I have anything else to say there. No, that's the lot. So just a reminder, we did the on Wednesday afternoon we did the or Wednesday evening we did the first 3. There was lit, motion powered light, and laundry alarm. I've shared the YouTube link for the recording of those, so I suggest you have a look through them just to see what your classmates have been up to. So who is up for Coffee King, and what do you want to share your screen and start off?
Yeah, hello. I will be sharing my screen for the presentation.
Okay, I'll get rid of mini me. So
All right, good to go.
let me just I'm just going to get that up on my recording side of things. So
Right.
there we go. Okay, go ahead.
All right. Good afternoon, everyone. We are the Coffee King team. I am Alex Silverman.
I'm Chris Hamilton.
I'm David Bordette.
All right. Just to give an overview, we got our introduction, block diagram, use case diagram, system behavior, go over the schedule, some pictures of our current progress, our budget, and then we have the challenges, the lessons we've learned, the effects of these lessons, what we would like to achieve to be considered a successful project, our conclusion, and some mid-project thoughts. All right, just to go over our problem statement and project summary again. About 27% of Americans regularly use a single cup brewing system like a Keurig. And a single cup brewing system would be better with a device that adds the cream and sugar to the coffee as it's being brewed. Many don't consider coffee to be complete without cream and sugar, and automating the brewing of coffee is only partly done by a Keurig. So this is our block diagram. We have the Arduino, it's basically the brain. The 7-segment display will display the numbers that are considered your user profile. That will connect to the laptop that will run all the programming. And those connect, the Arduino will run the servo motor for sugar distribution, the liquid cream pump motor, the low level indicator LED, which will let you know when your cream or sugar is low, the stirring mechanism, and then for the cream and sugar weight sensors, they are both connected to 2 separate HX711s, which is a 24-bit analog digital converter that takes the difference in voltage across the load cell and amplifies the signal for the Arduino. It basically just helps process the weight sensor information for the Arduino. Our use case diagram hasn't really changed much since we first created it. You got the person who needs the coffee who pushes the buttons to set your personal preferences for cream and sugar, and also to start the Keurig process. The Keurig will brew as normal, and then the Coffee King, controlled by the Arduino, will dispense the cream and sugar as it goes, and the Coffee King will let you know when either supply is low. So here's our system behavior flow chart. It's pretty big and pretty complicated, but it just sort of summarizes the logic behind what the Coffee King does. So for your user settings, there's two 7-segment displays that show the levels of your cream and sugar dispensing. They're limited to 0 through 9, so you can't go below 0, you can't go above 9. We have some buttons that you can press. If you press and hold it for a while, that's saving your preferred levels to a user profile, and a single click will load that user setting. There will be an RGB LED that represents the conditions of the weight sensors. Red means it's empty, yellow means it's running low, and green for full. And if the user starts the Coffee King and the LED is red, it will blink 4 times and tell the user to refill. All right.
So our schedule is not really. It's actually gone a little bit ahead of schedule compared to what we had in the previous semester, about a month ahead, since we're starting to 3D print in the second week of October. We thought we'd be a little, probably end of October, start 3D printing. Yeah, so we're about week 2.
Sorry.
Yeah, so we're about week 2, so it's just working on all of our features concurrently. I'm working on the CAD modeling and formatting the actual CAD model to print, and Chris is working on programming the LED entire logic of. Next slide.
Alright, so this is what our current project looks like. It's pretty messy. As on the schedule, we have soldering everything to an Arduino shield, or most of it. It's almost done. I literally need to solder on 2 more buttons and it's done. This is me showing the load cell. What my finger is on is the level weight sensor. As you can see, I've 3D printed a little bracket for it, but it's a little hard to see on the black background of my mouse pad. There's a couple buttons there that'll go and increment. The one on the left, which is for cream, and the 7-segment display on the right is for sugar. And then the buttons to, well, kind of in the middle there, are the user profile ones, and the one all the way to the right is to start it. This is me just showing, if I don't have my finger on it, then the LED, it turns red. It also turns yellow if I just don't apply as much force, but enough to get it to change.
For the 3D modeling, I'm currently finishing up the sugar dispenser. Trying to figure out how to, where it enters loft, the shape of the dispensing tube out, and that's some issues that I'll talk about later on in the presentation. And the Keurig is just a scale model I've designed, so when I finish the other parts, I can decide where they'll fit on. So for our budget, relatively cheap, except for Chris has decided to make the purchase of a 3D printer to help us get it done faster, and then Keurig is another big, not compared to the 3D printer, but it's a pretty big expense. So our budgets. This is for a DIY project. It's not very expensive, but for like an end consumer project, price point, it'd be pretty expensive at $400. Challenges. Our main challenge right now is we're all working on our own parts separately, and hopefully they'll all come together the first time when we meet up in the classroom again. We don't have to make any adjustments. And our work schedules, I work 30 hours. I know Alex works. And it's just trying to find time with school and work to work on this project as well. And Chris, you want to talk about the Arduino and C++?
Oh yeah. So I didn't really know much about like an Arduino. I'd always seen them before, but I never actually bought one and really looked into it. So I went and just found some kind of example code, and then when I tried to go and implement my own stuff, there was one line of code that just held us back for a very long time. And it's funny how just one thing will go and derail a whole project. There's also the 3D printer filament not sticking. There's a little switch at the bottom of the 3D printer that acts as the Z-stop, and that was just a little bit too high, and I couldn't get the bed up close enough to the nozzle in order for it to stick well and for the prints to come out well.
And then there's my progress in Inventor. I'm familiar with NX, and I'm familiar with other 3D modeling software, but Inventor is kind of new to me, so it's just translating those features into Inventor has been a little challenging.
So for lessons learned, early on in the project, I thought that an Arduino Uno would be enough for I/O for the project, but we needed a lot more digital outputs. So the money spent on an Arduino Uno starter kit isn't entirely a waste, but it definitely was about like a $40 expense. It probably didn't need to be made. We really should have planned more before, and I think we would have been able to if not for the virus. More planning should have been done. So I bought an FDM printer because they're cheaper. However, FDM printers aren't really considered food safe because it lays down like one layer at a time, and the concern is that bacteria can get in between the layers and grow. There are techniques to go and smooth everything out, and we'll probably have to implement some of those, and then designing and modeling at the same time. Because
that's mostly for me.
Oh yeah, it's also because when I print it, there's probably going to be a little bit of variance, so we might have to adjust the tolerances in the for the 3D models when we go and actually put everything together.
And also for me, just when I design and model the sugar dispenser, I'm running into potential issues and trying to design those out before we go to print.
So the challenges and lessons that we've learned have influenced the project. One for the weight sensor. So there's two different types of relay load cells that you can buy. One of which is basically just like a Wheatstone bridge. That one's a little bit bigger, and one side has to be held stationary, and the other side gets pushed down on or pushed up on, and that's how it senses a difference in weight. The one that we're using is a little bit smaller, and it's basically almost like a voltage divider. And that one takes the weight measurement in the center, which will be a lot more convenient for space saving. Also, as David said, redesigning stuff in order for it to print easier and make it go on easier. And there's definitely been a lot more hours spent troubleshooting and making sure that our code works well. For the success criteria, the copying should be able to easily and securely attach to the Keurig. As we said, we're 3D printing soon. Should dispense a precise amount of cream and sugar. the servo is set up to go back and forth how many times the sugar digit says, and the pump basically takes where that number is right now and multiplies it by 100 milliseconds. That can be easily adjusted later to dispense a little bit more precisely. It should notify you when the cream and sugar is low. We have one weight sensor completely implemented, and in order to get the other one implemented, that's basically just copy and paste. And I'll have to solder it up a little bit. Have programmable user buttons. We currently have 2 user buttons. If we think that we need more, or that there should be more, that is similarly just copy and paste. And that should work out well. And should keep the cream cold. We haven't really done much research into that. I was thinking using like a Peltier effect device. Just keep everything cold. But then we have to also worry about cooling the other side. Or, yeah, maybe like freezer packs. In conclusion, the Coffee King should be a pretty easy upgrade for an end consumer. Our device will add cream and sugar to the cup of coffee. The main problem facing us right now is the unfamiliarity with 3D printing and a little bit of the CAD modeling. Our project is going to take about $450 to produce, but a standalone unit should be able to be built for about $110. And mid-project thoughts. This is a lot more complex than I originally thought. Admittedly, I thought this was going to be very easy when I first decided on this project. Maybe I'm making it more complicated than it needs to be. That being said, we're very happy with our current progress being about a month ahead, and we might be able to implement a few stretch goals. One of them that I was thinking about would be Bluetooth, where I could just basically use a terminal app on my phone and make it brew a cup of coffee. Another real stretch goal would be Amazon Alexa support, and also maybe getting a board custom made for this project. Questions, everybody?
Okay, thank you, Coffee King. Does anybody have any questions for them? Okay, I have a few. Good presentation. Thank you for it. My initial question was I didn't recognise what an HX711 was, but you answered that during your presentation, so that's okay. I was wondering what goes into the user profile. Is it just the two the doses of the coffee and the sugar? Is that all?
Yeah, that's all that's stored.
Okay. And just as a follow-up to that, I would just stick with two profiles for now. It's the aim would be to get the system you're aiming for in the can and done, and then think about if I like that you're thinking about stretch goals, but get the thing done. The other thing that I've been saying to everybody is once you get things working to a degree, take a video of it. I've seen so many projects at the end of semester get most of it working and then something blows up and nothing works. So it's okay to get enthusiastic, but temper it with a little bit of documenting what you've done using a video or pictures or whatever makes sense. I had a couple of other comments really. The use case diagram, really the Arduino on that diagram is part of the system. It's not an external actor usually. It's just part of the thing that you're building to do Coffee King. Okay, and then the other again suggestion is that you said go to print. So every project I've been involved in where there's been a hardware component to it, we've planned in, usually if it's an electronics version, we've planned in three what we call spins of the board, right? Because there's usually something that goes wrong in the first spin. So even with just the 3D printing stuff, I'd suggest you plan on at least 2 prints for the components. Not saying you shouldn't try to get it right the first time. Do try to get it right the first time, but once you get the physical thing in your hand, you tend to get a different idea about what would be better or what would be good or what have you. And so I suggest that that may happen. Okay. Anything else? Oh, that's about all I had. I just had the couple of minor questions and then the comments. Okay, thank you very much. I think we have the Bear Aware alarm up next, so I'll close that session, and whoever on Bear Aware is going to share your screen, please share it.
All right.
Let me just, where's it gone? There it is. And I'll pop that out and I'll put that on my recording screen. So, sorry, it's Bear Beware alarm. I've been using Aware. That's okay. I should change that. Go for it, guys.
All right. How's it going, folks? My name is Thomas, and I'm joined here with Ray and Evo. And for our Capstone project, we're going to present the Bear Beware alarm. So, just a little bit of background. The black bear population has been growing in recent years, combined with modern expansion into the forestry of Connecticut. Bear sightings have dramatically increased. As of April 2020, there's been approximately 7,000 sightings in an 11-month period, with Simsbury having about 500 of those sightings alone. So I feel like it's definitely a relevant problem in our area. And bears are naturally curious animals, and even if they don't mean harm initially, they can be hard to deter safely. And especially if you have children or vulnerable people in the area, it's certainly a scary thing in towns like Simsbury and forests across Connecticut. So our goal is to harmlessly deter these bears without causing any harm to or any annoyance to nearby humans, and ideally no annoyance to other animals as well. So to accomplish this, we're going to emit a high-frequency signal that will scare the bear away and ideally protect your children and family. In order to accomplish this, we plan on using a Raspberry Pi core, as you can see from the block diagram. There's been no major changes from the diagram since the preliminary design last semester. However, we did decide to use a Raspberry Pi 4B instead of the Raspberry Pi 3 that we initially planned on. But we'll talk about that a little bit later. The core of the system, as I just mentioned, is a Raspberry Pi. It runs the Raspberry operating system, which is a modified version of Linux. And it's going to run the TensorFlow animal recognition and the Twilio SMS text messaging alerts as well. So the TensorFlow animal recognition will get a stream of images from the Pi camera and determine to output a signal. Oh, did my stream die? Oh, it's okay.
Yeah, it's good.
Oh, okay. Sorry, Discord gave me something. So as I was saying, the TensorFlow animal recognition will provide a flow of images from the Pi camera and then decide how to handle those images. It will essentially give a percentage of each object, or it will determine each object in the frame with a percentage if it knows what it is. And we will use a Python-coded script to determine if a bear is within the frame, and then play a high alert sound, or and to play a high frequency sound. The sound will be handled by the Hi-Fi Class D amplifier, which, as you would guess, amplifies the signal in order to be usable, because Raspberry Pi cannot output high frequency sounds natively. So essentially, it attaches to the GPIO pins on the Pi, and then outputs the frequency to the tweeter. So our system will be continuously monitoring the area in which it sets up. So if you place an object in the frame, it will detect it, and if that object is a bear, it will output a high frequency sound. And at the same time that the bear is detected, a text message will be sent to your phone. And with continuous monitoring, what I mean by that is it will check if the bear is gone after the sound is emitted. So if the bear is not bothered, you'll get another text message to let you know that, hey, there is still a bear in your area. Be careful. You might want to contact someone else. Although that's worst case scenario, and that shouldn't be a common occurrence. And I think with that, I'm going to hand it off to Ray.
All right. So the Raspberry Pi source configurations and installations. There's a bunch of installations that had to be done for Twilio and the TensorFlow API. That was done through the terminal window through commands. So the Raspberry Pi will run a Python script to operate the necessary components. Essentially, we're going to have to write a Python script that'll essentially automate everything that has to be done. So that's launch the object detection train, object detection, the audio file, and the Twilio message. So the TensorFlow with PyCamera to survey the area. So essentially, how this works is the PyCamera is the TensorFlow model detector has some like a sort of a box where it will identify whatever you've trained it to, and so hopefully when it detects, it will detect the bear and it will give us a percentage of how sure that is that the object was detected. And yeah, the Twilio API will be initialized by the script and send an SMS message to the user's phone. And the tweeter attached to have every amp will emit a high frequency audio sample saved on the Pi via OMX player. And what the OMX player is essentially it's just the native audio player on the command line or the terminal. So components, there you can see an image of our prototype there. And that's the Raspberry Pi 4. The PyCamera, which is modularly attached. The high frequency tweeter, which is that speaker there, you can see. That's attached with speaker wiring to the hi-fi berry amp. And shielding, that's essentially that box right there that you see. So we decided to use the Raspberry Pi 4. We're doing research into the object detection on the Raspberry Pi. We found out that a Raspberry Pi 3 it doesn't have enough power. It doesn't have enough RAM. So object detection would be at less than 1 frame per second. And so with the Raspberry Pi 4, we found that we get up to 2 frames, which is not a great improvement, but it's good. The Raspberry Pi 4 provides a 1.5 gigahertz quad-core processor, which is great when compared to the Pi 3, but not so good because it gets heated with the continuous use. And so we might have to look into heat dissipation, whether that be an external fan or a heat sink, which is possible, but we'll cross that bridge when we get to it. And the modular design for the Raspberry Pi was, it was so valuable to us because it allowed for simple connection. Here you can see a hi-fi berry amp too. And you can see the layout for that. The speaker is attached on those on the left and right pins, I would call it. And the great thing about the hi-fi berry amp is that it allows you to provide power to the hi-fi berry to the Raspberry Pi itself, which is great. You don't have to power both of these peripherals here. So on the right, that image there is a sample of the code used to enable the hi-fi berry amp. And the Pi camera is the setup on the Raspberry Pi is pretty easy. You just have to go into some simple OS settings and activate that. So yeah, you can see there a lot of really detailed things had to be done, like edit the config files and create an asound.config file. It's a lot of handy stuff there. So on this slide, you can see a sample of the Python code for Twilio that'll send out SMS alerts.
So this is just a template which can be customized to say anything. Ours will obviously send just say something about bears in the body there on the right.
Yeah. On the right image there, you see kind of like a sample of how this object detection works. So as you can see, there's one frame on the top left corner is less than a frame per second, and on the Pi 4 we have about 2 frames, which is great. It gives a percentage of the certainty of the image detected, and we're thinking we're gonna have to settle for a certain percentage for our project for our detection of a bear. Of course, if you're if we say let's say we program our prototype to be 99% sure there's a bear, you kind of want to know, you kind of want to keep a good chance that like maybe there's an error. Maybe you want to set it to 50% detection certainty just to be sure, just to be safe.
Yeah, playing with the threshold is definitely going to be a tricky aspect.
Yeah, we're gonna have to discuss that further, but yeah, there you go. And Ebo will take it from here.
All right. So in this slide, we have the budget, and it's split up into 3 parts. The proposed budget, which was our initial plan from back 497, then the revised and actual budget. Big changes happen here in the proposed budget, since our initial plan was to use a thermographic camera to detect the bear, because bears have a body temperature that's unique to them. It's very high. But we ran into a couple problems. One was that through our research, realized that because of a bear's thick fur and like their body fat, they're very insulated, so it's nearly impossible to detect them thermographically. And also like the price for the thermographic camera to get a ready-made one is very high. There were ways to make our own, but that would be a project in and of itself. So instead, we decided to go with a Pi camera, then use object detection, determine if a bear is present based on physical features, not body heat. A lot of those changes happened in the revised budget. With the actual budget, the main thing that changed was that we opted out of buying a case for the whole system, because how Ray mentioned earlier, we need to plan for heat dissipation. We don't actually know the final dimensions of the system, if it'll have a fan or a heat sink or something like that.
And we didn't want to restrict the heat flow while it's in development regardless.
Yeah. If we go to the next slide, it's our proposed schedule, which was also made back in 497. It's a very strict week-by-week schedule. There's not much to say with this slide other than we had to change a lot of this due to COVID and the social distancing and things like that. And we'll see the changes in the next slide.
And I feel like it was just a bit ambitious to get so much work done over the summer, as Professor mentioned.
Yeah. So here, this is the current proposed schedule that we've been working with. The main changes was that we decided it was inefficient to have each of us working on different parts and then having to move those parts around in between the three of us. So we had one of us, which is Ray, handle the hands-on technical stuff, while Tom and I handled the rest of the aspects of the class and the project, like documentation and stuff like that. Another big change was that we initially had the programming for the script first, since it's a pretty big part of the project, right? It keeps everything working smoothly. But we realized that it wouldn't have anything to work off of if we didn't do the animal detection first. So that got bumped up to September, and we pushed the Python coding further back. We're pretty on schedule for now, which is pretty happy with. For our criteria for success, since this is a project-based course, main criteria for success is to have the system detect a bear and only a bear. Once it does that, the next step will be to trigger the alarm and send an SMS alert. Once that's done, the project itself is pretty much a success, right? It works, and then our stretch goal for that will be to make it work continuously once we figure out the heating situation.
Yeah, and as I mentioned before, I feel like finding the threshold where only bears are detected and nothing similar is going to be a little tricky. But I think that's going to be interesting.
So I'll speak on this. So the technical skills needed, we're gonna have to know how to operate on Linux, since the Raspberry Pi uses a Raspbian OS, which is kind of like an offshoot of Linux, a build on Linux. The AMP2 configuration, which was easy enough to figure out, but again, it took a lot of troubleshooting. Not just physically, there was an issue with the Raspberry Pi that I found out, but also to configure it. Finding out how to actually edit a config file, which if you use Raspberry Pi, you can't do. You can't do in the UI. You have to do it in the command. You have to do it in the terminal, which it took me a while to learn, but I finally did. And the object detection model training took a very long time to create dimensional boxes, which you have to do for an image of a bear, which is what we're trying to detect. And I did that for over 800 images, so that took about like 2 to 3 hours. It was nuts, but yeah. So labor division. I'm basically one member is doing the majority of the hands-on work, which is what I'm doing here. I'm doing trying to do most of the hands-on work, since I actually purchased the Raspberry Pi, and I have future uses for it. So that's why I decided I would nominate myself to do that. Lessons learned: online tutorials. They're not great. They're very helpful, especially in video format. I prefer sometimes hands-on better. But your guiding source is very important. If in Python and installations, if they're not 100% accurate, you're gonna run into problems. I recently just figured that out, or I ran into that problem. I'm doing object detection training, the actual training of TensorFlow. It's very complicated. One line of code is keeping me from basically calling this project done right now. So yeah, Eva will take it from here.
So, in conclusion, we're pretty satisfied with how we've been progressing. It's been pretty steady. We haven't had any major hindrances so far, just some minor hiccups. If we continue at this pace, we'll be on track to finish by mid to late November. And after we decided to opt out of the thermographic camera, our budget reduced pretty drastically. So we have space in it for the cooling, to figure that aspect out of the project, and then after that, possibly get a case, make it finished completely.
All right, and with that, here are our references. And does anyone have any questions?
Yeah, does anybody in the audience have a question? So I've got lots. So sorry, was somebody about to ask?
I've got a question.
Yeah, go for it.
So have you tested the recognition software with like pictures of bears yet, or?
So the way
Pictures-
that okay, hey Ray, do you want to answer them?
Yeah. So actual pictures of bears, no, because that's where we're stuck at the moment on the object detection training, where basically you can train a model to detect the bear. Right now we have not tested it on bears, but we have tested the default models, which would detect a person or a dog, objects, playing cards. So that does work on our Raspberry Pi right now. We just have to train it to detect bears.
Cool.
Which is fairly easy, but
Yeah,
there's a line of code.
yeah. The one line of code's giving us the issue.
Cool. That was going to be one of my questions.
Is the cooling just for the like processor, or what exactly?
Yeah.
So the processor runs pretty warm, and usually it's not. Or on the Raspberry Pi, it wasn't really a problem. Passive cooling was able to suffice, but there's multiple accounts of the Raspberry Pi or the Pi 4 having an issue with the processor running a bit too warm.
Yeah, so I can actually speak a little further on this. So running the object detection wasn't bad, I noticed. However, I did notice when I was installing certain packages through Python, and it would require me to leave it there on for maybe more than half an hour. I did notice a little bit of heating. So yeah.
Yeah, I want to say there's something called it's called the Ice Tower, and it literally looks like a little almost like a really small like desktop CPU cooler for the Raspberry Pi. You might want to look into that. It works really well. It's only like $20 as well.
Oh, I'll have to
Oh,
check that.
nice. Yeah.
All right. Anything else?
Switch
Yeah.
out. They come to like a thermal pad. Switch out for thermal paste, I should say.
Oh, nice. Thank you. Any other questions?
Yeah, so that's good. I don't have to do anything. I did have one question, or actually two that I haven't heard. Why a Class D amplifier on the ultrasonic side of things?
That was just because the Raspberry Pi can't output that high of frequency, and we wanted to output a high frequency so that humans wouldn't have to hear the sounds, like your neighbor wouldn't have to get annoyed by your device scaring a bear.
Yeah, we did some research and we found out that a Class Z amplifier would be our best option here,
Okay.
along with tweeter.
And the other question was, and it's related to, you were saying you were getting 2 frames a second or so.
Yeah.
Did you have in your original requirement, did you have a detection time requirement? Like it's got to detect it within 10 seconds or a minute?
I believe we did, and we decided for 10.
Yeah, I think we gave it a pretty generous amount of time in our initial outline.
Right, so one thing you can do to improve the accuracy then, if you're getting 2 frames a second, right, out of your recognition, and you've got a buffer of 10 seconds, then you can say, well, if I get a detection in, 15 of the last 20 images, then that's going to be more reliable than just saying I get a detection in 1 image. Right?
Yeah.
Right. So you can play tricks. It's not just with all I'm saying is you don't necessarily just have the threshold as a thing you can twiddle with. Certainly adjust the threshold. Certainly do that. But then you can also look at checking. Like I said, 15 of the last 20 or 7 of the last 10 or whatever the number is. And sort of use multiple detections rather than just a single detection. Okay, thank you very much. That was very good. I think next up we have Aqua Drone, and whoever is from Amaziah, Jamie, or Zachariah, whoever's presenting, you've got the floor.
Yep. I'm gonna share my screen. Just figuring it out. Just real quick, are you able to see me change slides?
At the moment, I've just got a white screen that I'm seeing. Yeah, I can only see a white screen at the moment. I can see PowerPoint now, but when you go to slide presentation, it just goes all white.
Okay, but you can see it now, right?
I can see it now, yes.
Okay, cool. Yeah, so I'll just get started. Good evening, everyone. This is the Aqua Drone team. My name is Jamie.
My name's Amaziah.
And my name is Zachariah. So okay, I'll start first. So for the project overview, problem statement, just 5% of Earth's oceans have been explored and charted, especially the ocean below the surface. We want to answer these questions: how can we explore more? How can we discover more? And how can we find what's lost? Project overview summary. Our teams hopes to solve these questions with Aqua Drone. The Aqua Drone and underwater drone will aid in exploration, discovery, search and rescue, marine biology, hobbies, and much more. The Aqua Drone shall cost $289.49. And will be completed over the course of 7 months, May to December. We hope to create an affordable drone accessible to everyone. Success criteria: simple to use. It won't be complicated for anyone to use. Switches on the control box will be just for ascending or diving, moving right or left while in water. Affordable. The initial goal was $150, but with current budget, it has exceeded. Hoping for under 300 as the new budget goal. Most underwater ROVs can cost up to thousands of dollars. So keeping it in the hundreds is still a win. Travels underwater, basic functions of the drone with a maximum depth of 20 feet. Remote controlled through a physical controller with switches for movement. Display underwater environment. Camera attached to the drone shall display environment underneath the water.
So for our system behavior, basically just before we just wanted to explore, have a camera, display the video of the camera to the user. And initially we also wanted to bring some sort of like extended arm, like maybe underneath the drone to move or pick up any objects in case someone's lost it, which is the main thing we wanted with the drone, because we want it to be used by a lot of people who have hobbies, fishing, stuff like that, or if you drop something in the water, something like that. So now after we're kind of simplifying the system a bit, due to all the challenges we have, which we're going to go later on. But mainly, we just wanted to explore, display the video, and just have a controller that will control it. So here's our design update. So I just realized that the before and after are switched. So the after is actually the before. So in the Aqua Drone on the right, that is the before. Basically, we wanted the user to have a lot more options in terms of interacting with the drone, like searching, like I said, with the arm, moving things. Now, after, which should be the before, it's a lot more simple. Basically, we just wanted to display video and just letting people search underwater. So for the interface update, no changes really. Basically, we have our controller box, which is going to be the Arduino, allowing it to control the drones. And we're going to have 3 motors for it. And each motor corresponds with the type of movement it will go, in terms of ascending, descending, going forward and backward, and side to side. So here's a little before and after of our cost update. So before, we had about, the proposed budget was going to be $156.24, and after it obviously went up by 100 plus. Main things that we kind of didn't know, like a lot of tools mainly. I had to buy a lot of tools that will help us in assembling the frame. For example, the frame is being made of PVC pipes, and I needed a PVC pipe cutter. So that's like one example, because when I went to the hardware store, they only sold the pipes in certain sizes. I could have had them cut it the way I wanted there, but it would have just been a big hassle. So it's better I just get the cutter myself and do it how I want. So here's a little schedule update, a little before and after. Obviously, like the last group said, we're a little ambitious in the summer, hoping to get a lot of things done. That did not work out. Here's the schedule update again, this time for current month. Right now, before we wanted to be on the software side. Now on the after, we're focusing, for the main month of October, we'll be just mainly getting the frame of the drones ready. So the motors all attached, propellers, all that good stuff. And then in November, we'll start working on the control box, connecting the wires, the fuses onto the Arduino and making sure it works. And December, we'll just be prototyping and making sure it's ready.
Okay, and our challenges. So the first challenge we had was COVID. So due to the recent pandemic, the current semester was moved to all online, with most of the school's equipment and faculties unable to be used. Then we had another challenge with communication. Working in a team, communication is key. So we had trouble communicating with each other on the direction of the project. And lastly was engagement. We had to set a certain amount of hours each week dedicated to the project, and we all had conflicting schedules with work and stuff. Next is our lessons learned. Buy more. We had to buy more than needed, so our components were bought with a one and done purpose set in mind. The next lesson was importance of research. We took our research for granted when it came down to the start of the semester. And next was planning accordingly. We made the simple mistake of hoping things would go according to plan, not sticking to the schedule. In our conclusions. In conclusion, the problem we want to solve is creating an affordable drone to help hobbyists and professionals alike, no matter the job. The team hopes to design Aqua Drone, an underwater drone that shall explore and display underwater to solve this problem. And lastly, scheduling and budget will be assessed week to week. And this is our references.
And this is just pictures of the hardware. Whoops. Just pictures of all the things that we got. We literally just finished getting all of our parts last week. And this week, we're going to be working on or next week we'll be working on the frame assembly, which you can see the very long pipe, white pipe right there. I got about like 10 feet of it, so I got to start cutting it and working on it from there. But just showing you guys pictures of all the tools and equipment we'll be using. All the stuff in the little blue bags on the top left are a lot of DigiKey components for the board. And here's just a little more closer up picture. On the right, you can see our battery, more tools. On the left, you see some like T-shaped pipes. Using that to connect the frames and how we want the drone to look. And thank you for your time. Any questions?
Yeah, does anybody have any questions for the team? Thank you very much. Amaziah, Zachariah and Jamie. Okay, I've got a couple. I thought I saw something in the pictures, but I didn't see anything. One of the things I would be worried about with an Aqua drone is Aqua. What are you doing? What's the plan about waterproofing?
Yeah, so might be a little hard to see in this mess of equipment, but I see I bought a wax ring that will put wax on the motors to help it out there. I will have some electric tape. There's some little black tape above the wax ring, electrical tape. I also have some sealing tape on the top right-ish there.
Mm-hmm.
So, and in order to make sure it's completely secure, I have canisters, which are on the bottom right. So I'll be inputting the motors into each canister to make sure it's safe. So I have a lot of precautions for that.
Okay, yeah. I should actually share the video. Through the IEEE, we did we funded a group of UConn students to do a bit of a, what do you call it, a competition between a couple of groups of students there to do a remote controlled boat. Right, it wasn't underwater. It was just, but even remote controlled boat, they had problems with water getting in everywhere and making sure it all hung together. Yeah, to me that's the biggest issue.
Yeah, I did a lot of research into making sure the component was like nothing bad for wire in the water. So.
Okay, and the other, actually, it's sort of relevant to Coffee King as well. I can't remember whether the Bear Beware alarm had it, but so when you're in a company and you buy stuff for a project, there's usually at least two buckets that you pull the money out of. One bucket is the, if you like, the expendables, the project budget, and the other budget is the capital budget. And the capital budget is usually where you go to buy stuff like tools and things that are going to have a life after the project, right? So for example, the 3D printer from the Coffee King project, that would be a capital expense. Same with the tools, the PVC cutting tool, Jamie. That would be a capital expense rather than a. It would still be counted against the project, but not the whole cost, right? So that's usually the way companies work, where you've got an expense that needs to be made for a project, but has a life after the project. That's usually a capital expense rather than part of the project expenses.
Okay. Got it.
Okay. I think we're done. Let me just kill that, and I'll put my mini-me back up quickly. So there we go. So that is the last of the 6 projects for CET498, the detailed design presentations. Thank you very much for coming along. I'm going to share this video link from YouTube with the other 3 groups so that everybody can see each other's presentations. Please upload your presentation into Blackboard if you haven't done that already. That way I can grade it. And I have some other minor comments, but I'll make them in the rubrics in Blackboard. Okay. Thank you very much, everyone, and have a good weekend. I think we're done. Any questions?
All right, thank you.
Do we have to submit like journals or no?
Yeah, it's probably a good idea to submit journals, even if the only entry is we worked exclusively on the detailed design document and detailed design presentations.
All right, thank you.
Okay.